All right, again, we have the indeterminate form. We saw this 0 to the 0, and we can see pretty easily that that's going to go to 0 to the 0 by plugging 0 in for x. It's actually going to be kind of important that we're approaching 0 from the right, although not really. That just tells us that this is going to be a positive number and that this is going to be a positive exponent. So since this is 0 to the 0, we're going to do the same thing we did before. We're going to say f of x equals x to the x, and then we're going to take the natural log. And we're going to rewrite it then using our exponent laws for logs. And we take the limit as x approaches 0 from the right of x times the natural log of x. What is the natural log of 0? It's undefined. Here's where it's important that we're approaching from the right. We can't take the natural log of a negative number. So if we try to approach 0 from the left, this is going to just be undefined. And that's it. There's nothing we can do. But if we're approaching 0 from the right, then we're on an asymptote here, approaching from the right, and it's going to be actually negative infinity, right? So we're going to have 0 times negative infinity. This is an indeterminate form. It's the same form as 0 times infinity. So we'll rewrite it. I'm going to write it as a natural log of x over 1 over x. So in this form, it's going to be infinity over infinity instead of 0 over 0, but that's fine. And so since we have, and I'm sorry, I should have said negative infinity. So we get negative infinity over infinity. And so we can take the derivative here to evaluate this. What is the derivative of the natural log of x? 1 over x. And the derivative of 1 over x? Negative 1 over x squared, right? And then one of those x's is going to cancel. So it's going to be the limit as x approaches 0 from the right of negative x. It really doesn't matter now that we're approaching from the right because it's going to go to, what is the limit as x approaches 0 of negative x? 0. It doesn't matter that this 0 here is actually going to be a little bit negative. That's okay. So we go back to our original line here, and the limit as x approaches 0 from the right of x to the x is the same as the limit as x approaches 0 from the right of e to the natural log of x to the x. And we know that the natural log of x to the x approaches what? That approaches 0. So this is going to be e to the 0, which is 1.